My name is Adam Bean. I'm a freelancer working I'm working with Java and Java 6 and Java E, mainly with Java 6. About 90% of my projects in Java 6. And I'm usually in projects which either have some trouble or starting. It is unusual to me to be in a project which goes well, which is probably not a good sign. I'm usually hired as to help by task forces, stuff like that. And what I see, and I've spent most of my time in Europe, so all my experience is based on Europe. So I have no idea how it works here in US, but in Europe I can tell you what I encounter in my projects. And I would like to share the experience with you. This is my fourth talk, and in the course of the first 3 talks I got lots of questions asked like, what is the overhead of interceptors? Is JAX-RS slow? What is the overhead of EGBs? These are 3 questions I remembered. And I thought it is a lot more funnier to you and probably to me as well to show you on stage what the overhead really is, which tools do I use and how it looks like and how it operates. And then I can explain you how you can apply this on real world knowledge. This is my idea. So instead showing you 200 slides, I will show you a little bit more code and working deployable code. I think it's okay. Is there someone who prefers slides over code? No one. Okay. No managers here? Okay. Perfect. 2 books, somehow related because of time. These are great, but I have no time to explain how great they are. So, the green one came yesterday on Amazon. This could be interesting for you. So, in Europe, most of the project leaders, project managers, and QA departments are really excited about code coverage and unit tests. What I do not understand at all, because if you say you have code coverage of 80%, it could mean that your architecture is crappy and you tested 80% of getters and setters and 2 strings on hash code, but because of lack of time you forgot to test the 20% of significant code. By the way, how it works, you can ask me questions at any time. I really like questions. I don't like to speak the whole hour. So if you have questions, feel free to ask immediately. This is how it works in my sessions. So, and the strange thing is in Java E, if you think about this, a unit test is executed by a test runner in single-threaded mode. It means your application will never ever run in single-threaded mode. And I have to admit, I never had a problem because of wrong implementation of business logic. But we had a lot of problems because of memory leaks, bottlenecks, inconsistencies with optimistic logs, transactions, cache problematic. And these problems are widely ignored. So not ignored. In most of my projects, they are so-called load tests. And what load tests mean, at least in my projects, bigger project what I saw is, so I would say 2 days before going live production, yeah, they are starting the load test and praying that the load test is green. And if it isn't, can you help us, to tune the parameters so we can pass and go to production? So what it means, the actual testing happens always in production. And it never works, and this is why I'm actually busy. So because after that I get contract to fix the problem. And the funniest story is, I have a customer which hires me once a year after the release. And they never learn from that. And the last time, I sent him exactly the same emails as the year before. So look, we have to do exactly the same as last year. Let's do it. And what we did, I will just shortly explain. So why load tests are strange? Load tests are strange because they are, in my cases, defined by the business department, and they are more or less realistic. And realistic means there are lots of think time. And what think time means is like thread sleep. So you have lots of users and no contention. So I mean, with a usual load test, you can just test whether your system somehow meets the requirements, but whether it works, no idea. So this is why the talk talks about stress testing and not load testing or robustness testing. I don't care about load tests. So all systems and projects I saw, they are fast enough, but it didn't work. So more important to me is to try to break the system with massive load and see what happens behind the scenes. So before thinking about optimizations, just write simple code, perform stress tests, and see how it behaves. And you can learn a lot. This is actually my idea, but this is not very common. So in my project, okay, actually great, but we have no process for that. So because there is no process for that, we create our own process. So I will show you later what we actually do. Integration tests, a little bit more interesting. What I always do is I separate between unit and integration tests. Unit test means everything is mocked out, so it has nothing to do with Java 6, with Mojito, for instance. An integration test, either you are starting embedded Derby, for instance, or using great tools like Archillion, Graphene, or something like this, where you can actually boot the application server in process and test your dependency injection or whatever. Some infrastructural dependent code. So, stress tests. This is what I like. And how to start with stress tests. Just keep it simple. So the first day, although the best stress tests were created by students. So, and the mission was break the system. Here are the machines, generate as much load as possible, try to break our server. This is the best job ever for a student. Just hack the system. And the worst experience we have with, I would say, I'm also a consultant, I would say with consultants who make, doctor theses about how to create a stress test. Just generate massive load on the first page, login page. Also funny story. I was hired to evaluate one portal. And I started with the login page. And what in the login page happened is new thread start. And it loaded something asynchronously, which was actually expensive. Just with testing the login page, it was actually this year, I was able to create 1,500 threads. I was not even aware that the Windows system is able to handle that. And after 10 minutes, I told to my customer, see you in 2 weeks, because, it's already broken, They use Tomcat, of course, because of lightweight, I don't know what, but stress test. So, why we need application servers? So, this was already, so from my point of view, a little bit extreme statement, web containers are no more interesting. For me, never were. Why? What's actually very important in building enterprise applications is have a little bit more control over parallel processing. So what you can easily do with any application server, is just create a session bean pool, for instance, and say max size 10. What max size 10 means, there will be never more than 10 exact parallel transactions. Try that with Tomcat. Impossible. So it is very easy to break a Tomcat, because Tomcat does, or any other web container, because web containers have global resource management, and the application server are far more fine-grained. You can create dedicated thread pools and associate, for instance, with one single EJB, you can prevent denial of service attacks in terms of the application server will not break out of memory, for instance. What's also very interesting by application server, they come with JMX, Java Management Extensions. All my task forces based on web containers were more or less a blind flight. So you can connect to Tomcat or whatever web container you would like to. What you see is number of sessions, number of requests, and nothing else. Everything is POJO. So what we actually did in the worst case, we built in 6 weeks JMX monitoring from scratch for a Tomcat because it was too late, what you usually would get for free on every application server since J2E14. This is the crazy thing. So, and why is that? Because, at least in Europe, the development operations are separated. So the developers do not care about whether the system will work or not. They just create the business logic, write 80% of coverage, and pass it to production. And the pure production guys, they don't know the system, try to run it. In some companies, they just look at top, for instance. I worked with experts and said, does the system running? It's like, yes, the project is still alive. It's like, which project? PS works. It's like, okay, but everything else is dead. Okay, you see the Java process working. Does the system work? What do you mean by that? It's okay. Forget it, right? And these were enterprise experts, really. So, okay. After hard arguing with them, they told me, we need a Java course. Like, okay, that's a great idea. So, application servers, JMX, pooling, something like incoming queue, but this is also available in Tomcat. So you can see whether the application server is overloaded or not. Connection pooling, you can monitor connection pools, really interesting. So, and why is that interesting? Because if you try break the system, you have to monitor it somehow, whether it works or not. With a web container, you don't see anything. With application server, you see everything. But in my projects, no one was interested in the information. It was just widely ignored. They didn't even knew that the application server is capable to provide this monitoring data. Okay? What can go wrong? What went or can go wrong? I mean, static synchronized, and you have a memory leak. Synchronized, and you have a bottleneck. System out print line, and your scalability is damaged and can cause deadlocks. Single system out print line because this print line is synchronized. What else? Memory leaks. New thread dot start. This is a typical case. You only will find that in stress tests, never in load tests. Because the think time, you will get 300 users. 300 users, 300 threads is not a huge problem. Then in one system, they use Spring, which wasn't a problem at all. But what they didn't know is that Spring at default is a singleton. And they made it synchronized. And they built an own DAO system, of course, but and not JPA. But the problem was then that at certain amount of load, it just broke. And we weren't, because everything queued up, and the heap went up, and this was 32-bit JVM, so game over. So you couldn't do nothing about that. So, and my point is, you don't have to know everything up front, but you have to perform tests from day one and learn how it looks like when the application server breaks. You have to learn from day one. And this is actually fun. It is never done. And how it can work is, what we do, we create every night a stress test, which is run automatically by Jenkins. And in the morning, we look at the results and see whether it actually is still alive or not. And interesting story, regardless how simple the application actually was, it never survived the first few days. So either the connection pool was too small, or the thread size was too big, or whatever, it always died. But not in production. This is why the title is Without Stress. People have only stress because they never do it, and in production, they pray that the system will survive the load in production, or the hackers. Questions so far? Everyone agreed that web containers are not usable? This is a hard one. Oh, very good. This one. This. Yeah, Tommy is great, but Tommy is they recognize that plain Tomcat is not a solution. They build on Tomcat Java 6, and by the way, Tommy is very fast. I use Tommy for my current project for testing. It's just great. But Tommy, you know, is OpenEJB with this is a full stack application server. I mean. So it's got all the same game monitoring, all that stuff. Yeah, but I have to admit I never monitored Tommy yet, but I would like. JBoss is no problem. Glassfish, great. Even WebSphere provides monitoring capabilities. If you have enough time to boot, I would say. No? Then WebLogic and all others, they have a great monitoring capabilities. And Tommy, I will have to, never did it because it's too new. But yeah, okay. Other questions? TC server. Okay, I know about that. This is a great alternative to Java 6. I was asked about is Spring okay? Yes, I would. If I were forced to use Spring, I would use TC Server. Why? But it comes already with support, everything, and monitoring. TC Server is also not comparable to pure web container because it comes already with the monitoring capabilities. I'm saying just using Tomcat right now is crazy. This is my personal opinion. Okay? Very good. Yeah.
But one issue I see that
yeah.
typically as a developer, somebody develops they start with a small system that have very limited resources.
Yeah.
So in that case, how you can perform system?
Very easy. We can do it on stage with no resources. I will show you how, and you can. So this is continuous stress testing. So what it means, just to answer your question straight, I use JMeter as open source, and now is the first hack. You use the UI from JMeter to record a test or whatever. Now, recording tests can be hard. So the first hack is, I'll show you later, is what I always do. In case the system doesn't have convenient APIs, I create a servlet 3.0. In the doGet method, I implement my test script with Java and expose the doGet method to JMeter. Extremely simple. Okay, I have one simple URL and can access the server directly, and the server accesses in process my EGB CDI or whatever. And then you store the configuration from JMeter, and you can launch JMeter from the command line without UI. And this is the hack. And the command line parameters are JMeter, -n, -c. -n is no UI, -c is here configuration. Yeah, here's the configuration. And then write a shell script or batch file, and you can launch the test from Jenkins. All you have to do. Agreed? So the next challenge is, what if my system is dependent on legacy host AS400, I don't know, ZOS? Then you have to write a mock simulator or something like this. You have to mock out the external system. Otherwise, it is not always allowed to access the external system at night, for instance, right? Because the host can do something else or whatever. So then you have to write a simulator, which you would probably need anyway. Okay? Any other questions? You are tired after Java 1, I think. Load generation, not interesting. For me, for us, why? Because it is defined by the department with lots of sync time. It is nice, but not really usable to find out bugs, performance bugs, stability bugs. My personal theory is the more load we are able to generate, the more likely we'll find the bugs. It is not given that we will find everything, but we can increase the likelihood. This is actually the idea. Yes? Less likely to find bugs. It makes the test more realistic in terms of the system. The system is able to handle these users with the and without think time, we are able to find synchronization bottlenecks, and we can find out we can more easily break the server. Yeah, and and you can tune the application server and answer hard questions. For instance, can we survive 300K sessions? So I get the question a lot, and they argue in meetings. 2 days, what can we handle? Instead to launch a JMeter in 1 hour and see what happens. This is actually the idea. So with stress testing, you can reduce the amount of meetings, which is great. Okay, I cannot stand that. 8 hours, you know, then sitting on arguing about scalability on whiteboard, you know, and in 5 minutes we can find out on a laptop, you know. This is, okay. Monitoring. So keep it simple at the beginning. Use the standard technical monitoring, which is available by application server. And now it comes, what most of the systems are lacking is like, I don't know what the real name is, something like business monitoring. So how many orders we are able to process per second. Not how many transactions do we have, sondern more business. And you can do it easily with JMX, and of course EGB is the easiest way. With CDI, not so, because you need sometimes timers or something like this. It means you know what you are building, and you probably know what's interesting, so just expose that also via JMX, or even now comes the interesting part via REST. Because JMX is great, but the operations don't care about JMX. If you expose the monitoring data via REST, which is really simple, you can access from Perl, PHP, or whatever heck you have, the HTTP data and monitor that continuously. This is the first thing which can happen. It happens rarely in my projects because there is no use case or no user stories. So this is my fight with, how are they called, Scrum Masters. Say, no, the product manager has to define that, and the guy go to the product manager, and this guy don't even know what we are talking about. Okay, this is out of scope, I don't need that, okay? Extremely important to expose monitoring data, business monitoring data, okay? Then there is a concept called synthetic transactions. What synthetic transactions are is something like a ping, a real ping. It means an empty transaction. This is actually a term you can look up in Wikipedia. An empty transaction which passes all the layers and comes back, and you can see whether your system actually behaves correctly or not. So in some cases, I saw a synthetic transaction like GSP with Hello World, which was exposed in production even. You can imagine. So not Hello World, but some kind of GSP with useless data. This was used for a huge portal to see whether it is alive or not. Okay? Profiling. So if you are under stress, you can profile the system and get an idea how much overhead is generated by JBs, RESTful communication, Corba, whatever you have. And the problem with profiling is it's heavyweight. So heavyweight means most profilers changes the bytecode. They inject interceptors between the calls, and it's really slow. So now comes the hack. You know probably VisualVM. I will show you later. So VisualVM, the newer one, comes with sampler, which is great. So you have about 2 to 3% overhead, and you can. It is not exact because it samples every 100 milliseconds or something. The system, what it does, it causes stack traces and compares the stack traces. This is how it operates. So without even using in production in view projects. And what you see then, what is the main overhead of the system? So what actually causes the overhead? You will be surprised what it actually is. So EJBs, yeah. Yes. Pardon? On all platforms I'm aware of. So I'm using in Linux, Windows, and Mac. I have no idea about ARM. You didn't found that? Here is it. But you don't get my Mac. What you can do, visualvm.java.net. Then download the newest one, and you get the native package from Mac. You can drag it to application, it works. And always use the recent one, because sometimes if you have JDK 1.6, the VisualVM, which comes with JDK 1.6, doesn't have the sampler, just the profiler. And the profiler is not really usable. By the way, VisualVM is actually NetBeans. Okay, so on every machine you have a NetBeans. So, oh, J9? I don't know whether we were able to connect to J9, but you don't get all the profiling things. If you have IBM WebSphere, for instance, IBM WebSphere comes with a great, I don't know what it's called. It is built in the administration console called like performance something, and this is also great. So you get all the metrics right there. And if you have WebSphere, there is a great book like Administering WebSphere with Jython, which we can access via scripting API all the data as well. So, I mean, there is no excuse. This is actually the basic answer, yeah? dtrace? dtrace is great if you have Linux, Solaris, and Linux a little bit less. But what dtrace is, you are able to monitor the system from the JVM to the network drivers. For some application, may be interesting. For my application, it wasn't because we had problems with system out print line, or not, you know, it's all level. But dtrace is a great tool if you have Solaris. Very good. Other questions? So, where are my slides? Profiling. This is the last slide. Very good. So, ignore thank you. Thank you for your questions, but the thank you was for later. So, so first question: how much overhead is generated by an application server? So you cannot imagine how many hours I spend in meetings to explain that their overhead is not as expected. So, and the easiest way to find it out is just to see what it happens here. This is connected with Glassfish. Perform GC, and you see it uses right now 77 megabyte, but I already deployed an application, so it would usually use 60 megs. So if you use JBoss is very similar, and Tommy as well. I think JBoss is the smallest. JBoss 7 is the smallest one. So I measured but this doesn't matter. This is 5 megs difference. So and Tomcat is of course the smallest. I think Tomcat comes with 5 to 8 megs RAM. And in my projects, you have to imagine we have huge servers, and I'm in a room full of architects and managers. So okay, Glassfish consumes 60 megs and Tomcat 5, so we have to use Tomcat. So okay, we can we can save about, let's say, 100 megs RAM. Try to get go to Radio Shack or whatever and try to buy 100 meg RAM rig. You will save probably 2 cents, you know, with the Tomcat in production. And this is just crazy. Even space on disk, there's almost no difference. So all application servers I know, WebC is a little bit different, but it's getting better. The WebC 8 is really an improvement. It's like all the servers are about 100 megs on disk, and Tomcat is about 10 megs on disk. So there is no reason for resource consumption to use Tomcat, except you really have to save 20 cents, and then you have completely other problems, I would say, with your budget, you know. And so, this is what I don't get, and also the notion of lightweight and heavyweight, we have argued. Tomcat is lightweight, but the problem is there's nothing there, just a servlet. Of course, and what I saw is, no kidding, was 500 megs big. Because everything which was lacking on the Tomcat was in the war. And the architect told me it's a lightweight project. Okay, lightweight server, but not your project. And what I thought, my improvement was, this was not very serious, but they'd taken this serious, just package Tomcat with the 500 meg war. It doesn't matter anymore, you know. You can just ship everything and just start the war, like Jenkins does. And they saw then how crazy this actually is. So these times are over from my perspective. But the best thing is just connect with VisualVM, start the server without any optimization. This is actually a fresh installation, because yesterday I downloaded NetBeans Beta, and this is the Glassfish which came with the beta. And this is actually out of the box. So it grows because it has a max size 500 megs, so there is no pressure to release the memory. Okay? So these are the threads. This is a nice plugin called Stack Trace Explorer or something. So if you click on the threads, you see the stack trace. It's very usable if you have some deadlocks in production. So there are a couple of plugins you can install with the VisualVM. So what I have is Visual GC Thread Inspector. But you will find that it's just a, I don't know, couple of thread inspector and Visual TDA model and Visual GC. The Visual GC is a little bit more interesting here. What you see here is what the garbage collector actually does. So you see here PermGen, Alt, and Eden. During the stress test, it's essential to us that this doesn't move a lot. So this is the first thing, because this causes the major garbage collections. This is actually the first thing. So if you have the students, look at the green bar, it shouldn't move a lot, and if it doesn't move, is everything okay? The Eden can move, this shouldn't, and if this gets increased, we have other problems. Usually OSGI or something, static loaders or whatever. Pardon? Of course. Visual GC, Thread Inspector, and I think this was just this log file module. You will get installed because it's a dependency. So the crucial ones are Thread Inspector, Visual GC, and TDS is Thread Dump Analyzer. Okay. But the great story is you don't have to write that, because there are all available plugins here. You can just choose them here. So it's yes, not part of the installation, but you can choose them and download it immediately and reinstall it. So it doesn't, yeah. Yeah, the Glassfish plugin only works with all the Glassfish v2, but not with v3. Okay. Yeah, it would never be. Yeah, this is what I always do. In all stress tests, I just look at that and see how bad it actually is. Okay, this is the first thing. And this already amazes in most project leads. Wow, what is a tool that comes with JDK? Look on your disk. And then, isn't there? And then comes the trick. Don't start it with VisualVM, start it with JVisualVM. So, okay, now it works, you know? So, questions? Really? No questions? Yes, you can connect to the remote machine, then you have to run JStatD, I think. JStatD. But I don't like to connect to remote machines. If I'm task force mode, I always install where the server is, try to install that, because it doesn't matter anymore, and we have direct link to the JVM. Yeah, it is harder. You have to sometimes firewall issues with the connection, so you spend 2 hours for setup or something. Other questions? Oh, JRockit. So should I explain JRockit? So JRockit comes with a unique feature. This is great. It's called flight recorder. And what it means, so now comes the hack. If you have lots of trouble with Sun Oracle JVM, JVM, with locking particularly, the only way in one project we are able to find the deadlocks with JRockit. And the reason for that is there is no overhead during profiling in JRockit. Why is that? Because the JRockit needs the monitoring data for GC anyway, so it collects all the data. So if you connect with the analyzer, it just exposes the data as the only overhead. And for what flight recorder means, you can move back and forth what happened in the past. And this is great. So if you have, hopeless situation, try to run your system on JRockit just for bug fixing. I have no idea what the license actually is, but you can do it for bug fixing, but not in production, I think. We have to double check that. Pardon? Yeah, they're moving the tools to hotspots, but they are not yet. It will take some weeks or months. Yeah, for hopeless projects. I did it a few times. In all other projects, you can find a lot with that. Question or question? Then I could hack something for you, right? So let's say one project, very simple one, web application. And I call that load stress test is actually the idea. No? Stress test. Let's enable that. Finish. So I would like to start the application. It works. Then I would like to create a servlet. What I did. Performance gate. Org Java 1. Stress. Good package name. And then I would like to write here something. It actually looks nice already. And would like to test that. It was stress, I think, right? No stress. What was it? Performance gate. Thank you. So it seems to work. So now I copied the URL. Then I go to my command line. This is JMeter bin. And can start the JMeter from command line. And then I can say, I would like to have a new test plan. Threads. It always started with thread group. And I can say 5 users meets 5 threads. Ramp up period 1 second is okay for 5, but this is more, it should be longer. And they should loop forever. Then I add, there's a nice tutorial on JMeter, so you don't have to remember those, exactly describe everything on the JMeter page. I would like to create an HTTP request sampler, and this is the local host. Port number is 8080. Path was stress test stat. And then I need add listener, and there is summary report. This is just great. It just shows whether there's an error or not. Very important. And somehow throughput is interesting, so we can launch that. Run. Start. No. So, you see we have 8,000 node transactions requests per second, no error. And the Glassfish does something. So we have CPU usage of 30%. So it's okay. But what's amazing already is how many transactions? No transactions, no transactions. 19,000, can it be? Per second. So this empty servlet doesn't mean anything, but is running on application server. Okay? So this was the first setup of a load test. Now, no. So what we did right now, we access the server from JMeter. So just to show you how a JMeter operates. The problem with stress tests is I cannot look the whole night on VisualVM. So what we always did is the following. We exposed the monitoring data via RESTful Web Services, or JMX, then wrote a very simple application with Java, which gathered the data and stored the data every 5 seconds in a broad table. In the next day morning, we connected with BERT, Jasper reports, whatever, and draw nice lines and saw what happened at night. And then you can compare the days. You can say, yesterday was the performance great, but today it looks strange. So the challenge is to record the data. And I did exactly 5 times. It's okay, now it becomes boring. It's like I will rewrite everything in open source that. And it was a very simple tool, a view classes called Lightfish. So what it does does exactly that. It persists the data in a broad table, and you can analyze that on the next day. So the Lightfish is already installed. This is why I saw there's already one application running. And with a little bit luck, it starts. So if I start that, it would collect the data and it's over. The problem is you don't, yeah? Oh, I will show you in a second. So if I start that, it would collect the data or capture the data and we would be done. But I would like to see the data in real time. So I wrote very simple, actually in 3 hours, an JavaFX client. I can start the monitoring, and I'm able in real time to gather the data. And now to your question. That's the absolute minimum which I would gather. Is heap size, thread count, peak thread count. And why is that interesting? During the stress tests, you know, the average should be even. Nothing should increase. Neither threads nor heaps. If you have threads increasing, it means some threads are stuck or whatever. Transactions. So we have a number of commits should increase. Rollbacks is gray because there were no rollbacks so far, which is a good idea. This app, it actually doesn't matter because you can build it in few hours by yourself. This is an open source project called Lightfish with Apache license on the GitHub, so you can download everything. You have exactly that. But forget the application. This is just, it visualizes what happened on the application server, and the Lightfish accesses the REST monitoring data from Glassfish. One Red Hat guy on this conference asked me whether he should implement a JBoss binding. So sure, there's one class, do it, and I would include that. So we will get JBoss 7 for free. Probably tomorrow if you have is a boring flight time. Yes? What's the D? To connect to HTTPS? There is here, you can use authentication and you use the HTTPS. So paranormal activity is more interesting. So open source should be fun. So queued connections. What queued connection means, the server is overloaded. It means the connections are queued and they are no more able to process them. Very important. So errors means there are no errors, and busy threads count is 1 thread. Then performance, I built it actually on the flight here. So you see transactions per second and rollbacks per second are not transactions, are true transactions, not HTTP requests, but real transactions. Web, HTTP sessions, and expired sessions, also interesting. And now just which applications are installed and which resources, JDBC connections. And this would be the absolute, no absolute, this is what I used in my projects. Okay? Question asked, I think, right? So we can just start the performance again. Where is... And you see peak thread count, we have about 100 transactions, adjusted transactions from Lightfish itself. Queued connections 1. So something happens. Busy threads count 3. Performance, no commits per second because we don't have transactions. Web, 2 HTTP sessions and expired sessions. So now, the yeah. I did. This is not VisualVM plugin. It's JavaFX application standalone. Why I did it like that? Because I only had 3 hours time. Really, I was in a train from between Frankfurt and Munich, and it was boring. It's like, oh, let's do that. And I did it with 2 charts in the table. This was the first proof of concept. And even funny story, I showed it by a customer, and there's one HTML5 guy. It's like, why you didn't build that with Raphael.js and JS? It's like, because I only have 3 hours time. So, okay, then you're right. Other questions? This is what I would like to show you right now. So, as you see, the Lightfish administration is a JSF console, JSF application. So I would just invoke that, and it should increase the number of sessions. Why is that interesting? Most common questions. How many sessions an application server can handle? So instead of, so we say, okay, I would like us, I would right now to go to Lightfish straight. Lightfish. And start. And you see number of sessions. We have 600, 1,000. And now we can open, for instance, where is my VisualVM? Here. And you see the memory usage. So what we learned so far, 5,000 sessions cost about 200 megs. Okay. So, and if you, for instance, just playing with that, if this is a real Lightfish that is already running applications. So if you have applications like that, just to try to break the system. So, you know, ignore JSession ID, so it will start on new request, new session, and you will easily see what happens behind the scenes and how big a session really is. Okay? So amazingly, we are about 25,000 sessions, right? On 400 megs of memory, shortly before out of memory. So it will mean with this configuration, out of the box, we're able to handle 70,000 sessions. A funny story, because of scalability reasons, one architect forced us to build stateless systems. And there were 300 employees of the company. And we, and because of error, configuration error in stress tests, we created in the first night 30,000 sessions per node, and we had 4 nodes. So we were able to have 120,000 sessions. The next morning I told him, look, we are able to handle 120,000 employees. You have only 300. We scale well enough, you know. We have some room. Say, yeah, but in the future, and you know, and this is the discussion is really strange. So just test it. It is really fun to play with. So just test it, and most of the developers are amazed how small actually a session is. Okay, so next hack. So we have VisualVM, and there is a heap dump. So now, create a heap dump. This was actually a bad strategy because it is already big. And there is a great exception, an Eclipse tool called Memory Analyzer. Comes for free. Because it is Eclipse, you have to be a little bit careful what we are downloading. There is a plug-in set and 1,000 different possible configurations. But the most common one is a native installer. This is what you should download, the native installer. If you launch that, it's a great tool. It's able to analyze the heap dump and show you how big the objects are and how they are connected. And this is really great to find memory leaks. Question? No. This is Lightfish sessions. So what I did, I just hack Lightfish itself, you know. This is the monitoring application, create session per each request. So it isn't empty. It is all the monitoring data is already there. So I monitored actually the Lightfish, which is small but real-world application. It isn't empty. It isn't a servlet. It is Lightfish. Mm-hmm. In worst case, in do-get from servlet. This is the easiest way, I have to say. Before I record everything outside, I can use this. And if you have tools like LoadRunner, for instance, I don't know, this changes companies frequently, but it's a great tool. So you can use it to record the windows as well. So this is the best tool. But usually you don't have the resources or the licenses to do that. So with JMeter, it is just fine enough. And what JMeter is able to do, JMeter is able to record the HTTP traffic as well. So open heap dump, I don't have to store that yet. But I will just skip the memory. We have 15 minutes time, so I would like to concentrate on more stuff. But with memory analyzer, you can just walk through the heap and see how big the objects are. It's very, very simple, very intuitive. How to find memory leaks is another great tip, hopefully. It worked in my cases. It works always with NetBeans. So what you should do, if you have memory leak and you cannot find the memory leak, you can connect with NetBeans. And there is the last column in NetBeans is called generations. And now come the hack. What generation means, how often the objects survive the garbage collection cycle. And I sort the column by garbage collection cycles. And if you have memory leak, you will see something like 190, 80, and the third row is like 10. And this gap indicates you have memory leak. And in 90% of all cases, if you go to the first line, the first row, you will find the memory leaks. This is the object which causes the memory leaks. Yeah. NetBeans connection profiling. Sort for generations. If there is a gap, memory leak. Then go to the first row, right mouse click, take snapshot, and you know which object it is. This was a virtual wizard. Yeah. Yeah. If you cache the object, they will survive, and you will see that the root is, for instance, Eclipse on Hibernate. And then you have to decide whether it's okay or not. But you will see how big this is. This is the great story. So that you can compute with a memory analyzer the cumulative size. So you see how big this really is. And it's a lot easier to do that, you know? Okay? So, what I also would like to do, or I can ask questions. I would like to implement an EJB and show you the overhead, but it is fun, but you don't learn anything new, except you will see that we will only have 5,000 transactions per second about. Should I ask a question? As I will try to hack that. If you have questions, just ask me. So I try to be multitask. So, yeah, in a production system, you have to create it up front. So you specific transaction with specific ID, whatever. The system knows that this is synthetic transaction and there's no side effects. So this is, you have to know it from the beginning. But all big systems are working that way. So they expect for you synthetic transactions. Very good question. Other questions? On my machine, I was open everything so far, and the biggest were several gigabytes. So several gigabytes you can open, it's no problem. And even before that, but I had 8 gigabyte RAM, and you need 64-bit JVM. But it will take time, but you can open nearly everything. But about several gigs under 10. Above the 10, I never tried that. Yeah. No, I prefer a memory analyzer from Eclipse for that. Not NetBeans. NetBeans. I use NetBeans for profiling and finding memory leaks. Okay. Other questions? So now, what you learned is apply these techniques. So what you should do first. So just to summarize, because we only have 10 minutes. So provide expose first technical metrics, and which are interesting depends on your application. What's critical, from my point of view, number of rollbacks. Why? Number of rollbacks indicates, for instance, you have lots of optimistic log collisions, for instance. And this indicates you have to clear the caches or invalidate the caches or something similar. So we had, for instance, to invalidate the caches in one project because of that. So you will find a certain amount of load, you get lots of rollbacks. Optimistic log exception, caused by optimistic log exception, critical knowledge for you. Then, connection pool size. And why? Often the connection pools are completely forgotten. So if you have max pool size of 10, you will never get more than 10 parallel transactions. Everything will queue up. So this is also critical. Then if you have JMS, it's the same story. You can monitor JMS resources, JCA resources. And this matrix on what you should do at the first day is just visualize them on a chart and see what it actually means, how the system behaves, what we can reach. And from day one, you could be able to estimate what we can actually handle in production. Okay? So having that, you have to conserve the data. And in my case, it was Derby. So I just zipped the Derby. This is what day 1, 2, and 3, and 4. You can provide additional column in the database and compare the days. And now it's also important that these tests are performed automatically. What it means, what the JMeter did, created a file called something.jmx. This JMeter configuration, I think, this or XML configuration, something like this. So save that in your repository, check it out with Jenkins, and run the last stable builds the whole night, stress test like that. In the morning, the application server should survive. The next trick is measure the most expensive SQL queries. So we do not optimize anything at the beginning. Then if you have Oracle, use the Enterprise Manager or whatever tool you have, and just optimize queries which are really critical. And what we do, we have kind of dashboard, which is, I mean, a screenshot basically. And if you have Scrum meetings or something like this, it can go, say, okay, let's see, your queries was the most expensive one. Should we do something about that or not? So as the project evolves, just take more and more metrics and remove the old ones if they are uncritical. And you will see how much you will learn. The strange thing is, also it is fun. It doesn't cost anything, so we are able, I mean, I would like rather answer a question than monitor the EGBs. We could inject the EGB, we'll see how EGB performs. And in minutes, you can have such a system running. It doesn't have to be perfect from the day one, but if you're starting from day one, the first day, you will probably just monitor, the login field. The next day, you can evolve the system with the business logic, which is a lot easier than afterwards. And you will see, so okay, I'm lacking this on this metric, right? And you can create it from day one. You will see, oh, what's interesting. For instance, my block statistic software, I wrote a block system. I was surprised why I built that, because, okay, it cannot be that my block can handle that traffic. So I built a system to see what it is and what I exposes number of hits per second. From where the users come, this was actually my monitoring data I exposed via REST, is business data. In my production environment, we have a number of orders per second, number of whatever, heap, then slowest methods. Extremely simple. Just create an interceptor, measure the performance, and solve the methods. I mean, you get it for free. What's also interesting, which methods cause exception? A hash map with an interceptor, right? So you know interceptor, so you can catch all the exceptions, you know the method name. So you only have to put in a hash map, and you can count which method caused how many exceptions. What I see instead is they are writing logs like crazy and then try to parse them in the year 2012. So what we could do, we can learn in real time what the system actually does. And my point is, it's very, very, very simple to do that. And for instance, what I try to avoid, put such statistics in log files, and if my customer says we need that, then we store it in the database because it's a use case. But I don't know that because I use it as JMX and expose it immediately to database or whatever. But I don't write extensive log files and then tools to process the log files, just crazy. And in most projects, I don't even have access to the production. So you can just request the log files and get the log files after 2 weeks, which is, crazy. So, other questions? 5 minutes for questions right now. Yeah. Also then I have to, I have to build that, right? So, slow bean. No, just slow is better. So then. So, and the interceptor would look like Full names are important. So now we have the method. We have parameters. And you have the exceptions. This is the interceptor. If the interceptor, if you are interested in that, check out X-Ray. This is the block statistics software. I monitored everything with such interceptor, and this is, I think, also Apache license. If not, I can change it for you, don't matter. And you can just download that and steal the interceptor. This is already implemented. X-Ray, you will find it on my homepage as well. But this is pseudocode of the interceptor, right? So you have the method, so you get the method here. You have the method, you have the name. You have number of parameters, which is not that important for monitoring. And here, what I forgot is around invoke. And this would be an empty interceptor. So we can here, for instance, already monitor performance or something, right? So, and we could inject the performance gate here. Performance drone. And I could invoke it somewhere. What was the name? Drone. Not the drone. They're slow. No drones here. Oh, was okay. Slow method, and then we can change my script from, what was it? Stress test, you know that? No. Something like that, and then performance gate, exactly. This is what I need. And we will able to perform the same test with an EJB. So save that. We have to clear the results. Clear all. Table is empty right now, and we can re-perform the test. Still fast. You see the transactions, performance, 2,200 transactions per second with an EGB. So now the next question was, which is actually slow? I think because the application server is almost on the boundary to out of memory. So, so we introduce an EGB. Now we measure the performance of EGB, transactions going up, thread, and paranormal activity. Queued connection 1, still boring, so we could increase the load. Okay? But with think time, we will never see the contention. The queue will be always empty. There will be just, you know, happy living, and nothing would break. Okay, the interceptor is not measurable. If I would activate the interceptor, it would take about 1 millisecond per call or something. It doesn't matter. So, questions? To set up the interceptor? Okay, what I did is the interceptor sent a CDI event. The CDI event can be received by a EJB, which is asynchronous, for instance. But because of Heisenberg, there is no, if you measure something, it will have impact, you know. Other questions? Yeah. Oh, can I disable or enable interceptor on condition? No. But what you could do it within an interceptor with JMix, for instance. It's possible. But you cannot just drop the interceptor. Okay? But you can activate interceptors easily with portable extensions. This is what you can do, and I've wrote an article for Java Magazine, so a free oracle about aspects in Java 6 or something. So I did exactly that with source code, so you can check it out. Pardon? AOP, Aspect-Oriented Programming, for Java Magazine from Oracle. It's the free magazine, so you can just check it out. Questions? Enjoy Java 1, and see you next year.